You should see my screen okay now?
Yes.
Perfect. Okay. So thanks for the introduction, George, and thanks everybody for your time, just for 10 minutes just to talk through this proposal. So the proposal is for an enhancement to the Times source code, and it's basically that we want to be able to enable definitions of model regions and model time slices to be defined on a per period basis, and I'll explain why that might be useful in a minute. So the project partners are myself, Evangelos Panos in PSI, Antti Lehtila in VTT in Finland, and Amit Kennedy and Canoros in India, and we're requesting a budget for €55,000 over the year from January to December next year. And what we propose to do is to enable nesting of spatial and temporal resolution in the Times source code, and in Veda 2 to be enabled to parametrically scale regions and time slices within the Times source code that enables us to do certain things, one of which being to explore structural uncertainty in our models, I should say. So some introduction and some context. Increasingly, there's new spatiotemporally granular data sets available that are useful for energy systems modeling. So the example being open data sets on power system locations, their capacities, their locations, their field types, etc. So Times is a flexible framework that could take advantage of these new large data sets of individual unit process dynamics and incorporate their geospatial dimension with high temporal resolution in the Times reference energy system. So spatially, we already have Times models that are developed at a city level, and we have Times models that go up to the global level, like it's at PM. Temporally, we have Times models that are running at hourly resolution at the subnational scale. However, there is a useful need to integrate high temporal and spatial resolution into specific time periods and locations in conjunction with more aggregated structures within Times models along the Times model horizon for multiple reasons that I'll outline. So this code enhancement would enable zooming essentially on the temporal, technical, and spatial dimensions in our model. One of the reasons that this would be useful is that we could have near-term high temporal, spatial, and technical resolution so that we can model things like NDCs to 2030. And then in the more long-term, we could have more aggregated spatial, temporal, and technical resolution where the medium and long-term is more uncertain. This would enable us to model to have more accurate representation of local air pollution, where spatial intensity of emissions really matters to estimate damages. So we could have high spatial resolution in early time slices or in future time slices, but not have high spatial resolution at all periods. It would enable us to capture constraints from climate impacts, where there's specific impacts and variations and extremes like floods and wind speed variations in the future, or solar resource variations in the future. It would also enable us to explore structural uncertainty, not just across the usual Monte Carlo type uncertainty of inputs, but also explore uncertainty in our spatial calibration and our temporal calibration of our models. And a nice co-benefit would be that by zooming and having complexity where and when in our model that we wanted, but not throughout all regions and all time periods, it'll enable us to reduce the solution matrix size, which can enable complex models to run faster on desktops or on servers. So as I said, what we propose to do is to enhance the time source code to allow time-varying nested regional definitions alongside what we've already tested, which is time slice definitions per period. So as I said, this will enable Times modelers to model with high spatial and temporal resolution in the short term, while varying spatial and temporal resolution in the long term. So how we propose to do this is that we would have to map region definitions and time slice definitions into groups of sets so that they can be coordinated within the GAMS code. So the examples that I have here, or that we have here, I should say, is that we have 3 normal regions and 3 sub-regions. And then we have these mapping tables that would be required to show in which periods the large regions, so region 1, 2, and 3 exist, and then which periods the sub-regions exist. and mapping them together. We also need to figure out how constraints would be mapped across these time slices, and what would feasibly constraints would be feasible to aggregate across these time slices. So the work packages, we've broken this out into 4 different work packages led by different groups and then coming together in the deliverables. So work package 1 would be a detailed mathematical formulation design and agreement that would be led by myself and Evangelos, that would go through the maths, the algebraic formulation, and to design in detail the desired functionality. This design then would be reviewed and agreed upon by myself, Evangelos, Antti, and Amit. Then Antti would extend the time source code to enable this functionality once the design is agreed upon. Antti would test the formulation, would implement it in the time source code, develop a demo model, and would write up the documentation. Work package 3, Amit would enable additional UI functionality to enable this parametric region and parametric time slice definitions. And then we would test it in work package 4 in a high temporal resolution and high or multi-regional times model. So EU STEM is one such model that we could use that PSI have access to. So the deliverables would be an updated time source code, documentation, a project report, an application and a multi-regional times model. And we hope we could do this, we can do this within 12 months next year. The budget that I've already outlined, just in summary, it's a total of €55,000 split across the work package 1 is €12,000, work package 2 is €22,000, work package 3 €5,000, and work package 4 is €16,000. The contributions then to Annex 15 is that the innovation, so it's a source code model development, and so by its nature, it's innovative, it's cutting edge, and enables time source code to do things that it couldn't previously do. The benefit to the partners is that the project will enable enhancement of the time source code. It'll benefit partners in that they'll be able to better explore research areas of interest, advanced unit commitment with higher technology resolution. It'll provide opportunities to better explore representation of local air pollution, demand modeling, and climate impacts. The benefit to the ETSAP community, it'll enable us to explore in more detailed flexibility and to answer questions that we couldn't answer before around net zero energy systems, variable renewable energy systems, and variable resource potentials. It'll also enable us to explore structural uncertainty in our model that we can't currently do. And then the relevance to Annex 15 topics. So it's an update and improvement of the time source code, which is a minimum objective of the Annex. It's improved modeling of variable renewables and short-term operational issues in context of long-term modeling. It's improved modeling consumption side and energy systems and demand side flexibility. And it would enable us to integrate human behavior and societal aspects into energy systems models. And then the cost effectiveness. We think this project leverages existing expertise, working relationships, and advanced knowledge of times, GAMS, and data tools, and probably wouldn't be possible outside of ETSAP with this team. So I think that's all that I wanted to say on the proposal. So I'll welcome any questions.
Thanks, James. So if you can go ahead and answer what Pernille sent on chat.
Okay.
See that?
I just have to find it here. Yeah. In the chat or in the questions? In the chat, I guess.
Chat, yeah.
I don't see the chat, George, with my screen maximized.
So Pernille says that, is there other research that support that it's a good idea to have a coarser temporal resolution at the end of the model horizon? She's especially thinking about modeling of energy system models with a large share of intermittent renewables.
Well, I'm not sure about the the granularity at the end of the model. We know that certainly some of the global models that are available are using things like low duration curves that underestimate install capacity from VRES overestimate the potential for VRES in the near term. And so that's one of the main reasons to try and focus on this, to make it tractable to have high resolution in the near term. Regards literature on the uncertainty in the long term, I'm not sure. I haven't read up on it, so I don't know if there is literature recommending that.
So in principle, what you're suggesting will automatically do this allocation between different time slice definitions rather, right? So the distribution of demand over time slices will be automatically handled, and the distribution of production of variable rates over time slices will be handled automatically.
Yes, there will be some need for the user or the modeler to appropriately define those per period. So right now you would define demand fractions or commodity fractions for your model period, but now in the future you'd need to model those going forward, but then the time source code would be able to solve across that different granularity is the proposal.